Welcome to today's episode of TheSquare. We are continuing our conversation about the relationship between water and design. And we started this series, as we've gotten more in it, we're constantly reframing how we're approaching it. Thankfully, to help us navigate that, I'm joined by Samantha Flores, who is the director of Hugo. Thanks for being here, Sam.
Thanks for having me.
And in Ireland, it may or may not be because Taylor Swift happens to be playing there right now, is Varun Kohli, who's our director of Echo.
You'll never know, Brandon.
and then we're also joined by Aaron Tartakovsky, who is the co-founder and CEO of Epic Cleantec. Thanks so much for being here, Aaron.
Thank you.
You definitely get the award for getting up the earliest since you're in San Francisco and it's 6-something in the morning.
There's. Sorry.
No, go ahead.
No, I was just going to say, I think there's no better way to start the day than talking about wastewater. So let's get ready.
So as we, started to wrap our minds around this entire, very, very big topic, I think I saw an estimate that by 2025, 2/3 of the world's population may face a water shortage. But we realized that we needed to start talking about it and really dive down into the micro level with the building as a starting point. Tell me a little bit of why, Sam.
Well, I think that bringing our attention to water is extremely important, not just as what users of the buildings can do, but what designers of the buildings should be prepared for or should be planning for or designing differently. I think, hopefully it's basic knowledge that we should be using things like low flow fixtures or timers on faucets or, different water management systems in daily operations. I still think that that's being worked through as designers as we start kind of, choosing those fixtures. I also think that there are other ways that we operate the building that we could be reducing our water usage or, making sure that we're being more responsible about it. There's also things that we could start designing into our buildings that sometimes seem superfluous when we're designing and may sometimes become VE'd out. But, really things like green roofs and water harvesting systems, those can be extremely important to not just saving water or helping us reduce our water footprint, but also to reducing urban heat islands, which is becoming a huge topic of discussion as we see our temperatures in our cities climbing and becoming a health concern. And in fact, one of the things that causes the most deaths in the U.S. right now is being over-exhausted from heat. So I think our conversation around water is extremely important right now. You mentioned, 2025. Yeah. That's next year. I mean, by my count, it's in 6 months. Yeah. So we have a lot of work to do to get to where our buildings are becoming more and more efficient just by basic design principles that we're looking at. And then I also think there are things that we should be aware of as designers with our suppliers and our suppliers down the road. Who is helping to conserve water in the manufacturing processes, for example? So there's a lot that we as designers in the architecture space and the AEC industry need to be considerate of when we're designing our buildings.
Aaron, why don't you jump in here? I know that you have been able to, with your career, approach the idea of water and design from a couple of different directions, whether it's with Epic Cleantec or and on a policy level. Tell me a little bit about why you're passionate about it and then your thoughts on the relationship between water and design.
I think water is this really interesting thing where, as you noted, it very literally touches everything. It touches everything we do. We are made of water, but yet we as a society know very little about how our water systems work. I often say we live in a flush and forget society, which is to say we don't think about what happens after we flush our toilet. When we turn on our tap, water just magically appears. And it's great. I mean, it's a marvel of modern engineering that we can live that way. But unfortunately, what we're finding out now is that the status quo is no longer sustainable. I mean, here in California, you just drive from San Francisco down to Southern California, and you're driving through the heart of California and really the nation's farmland. And you're seeing people putting signs up saying we don't have water. You're seeing sort of large swaths of farmland that are going down. And we see that everywhere. And so I think there's a huge education component to this, but I think there's also a big policy background, which we can talk about. But I think ultimately what it comes down to is that the combination of aging infrastructure, of urban population growth of 70% of the world's population living in cities by 2050, and then a changing climate, which is, as you said, it's making everything more extreme. The wets are wetter, the dries are drier, the hots are hotter, the colds are colder. Everything is more extreme, and so we have to do things differently when it comes to water. And so I think that's why we need to be having conversations like this one.
It's interesting that you say that. I literally just got back last week from being in Colorado, and where I was is super remote, 100 miles from the nearest Walmart. That will tell you how, we're just going to have to orient ourselves by Walmarts. But while we were out there, the second day we were there, we lost water in the cabin. And we had just, because we're so remote, we are obviously drilling our own well. They had just drilled a well. And so we couldn't figure out why. And what was happening is there was a bunch of dirt and silt that was coming up in the new well that was getting caught in the filters, and it just turned the water off. And so for almost a week, I was having to change filters every day, something that you do maybe once a year. We were having to think about, okay, well, we're not going to shower here. We're going to go over to a different place and shower. How are we going to do laundry? And it was one of those things you just, like, I was talking to my wife, she's like, she said, I wonder if I would rather be without electricity or without water. And she decided she'd rather be without electricity. Yeah. And it just is, to your point, Aaron, it's one of those things you don't think about. But in this instance, and it was kind of a kismet because we're talking about it now, it made you think about how important water is. For being in the city where it's even, you don't have those experiences where you can be without water on a normal basis, how are you and how are Epic Cleantec bringing to the forefront that idea of the importance of water and the responsibility for water?
Yeah, look, I think to your point, the context is important. I mean, I think we as a company got our start out of work with the Bill and Melinda Gates Foundation, something called the Reinvent the Toilet Challenge. So if you've ever seen those videos of Bill Gates drinking so-called toilet water on Jimmy Fallon, that's where we got our start as a company. And we really started focusing on parts of the world where it wasn't just about, whether water was going to be there that day. They didn't have water at all. There was no water, there was no sanitation, and that's true for large swaths of this world. Now, shifting to the United States, there are millions of people who don't have access to clean water and reliable sanitation. But I think what we're talking about here is, a lot of the folks who are living in our urban cores. And talk about education. I think part of it is, again, look, we've literally built our infrastructure to be underground. We put our facilities away from city centers. It is very literally out of sight, out of mind. So there is a huge education component to put this back on the radar. But the way we view things as a company is that buildings globally use 14% of all available fresh water. So all the potable water, 14% of that used by buildings. If you look at the rate at which we are adding new buildings to our global building stock, it's like adding another New York City every single month from now until 2060. So we're building a lot of buildings. Buildings use a huge amount of water. We need to be doing things differently when it comes to that water, and that's what we're focused on as a company. And it's through technology, it's through regulation, it's through business model innovation. Those, I think, are the key sort of things we need to touch on to introduce a new way of incorporating sustainable technologies into our designs.
Off of that idea, Varun, the idea that traditionally the utilities have been hidden, and so out of sight, out of mind. As a designer, is there a responsibility to bring that more forward so it's more front of mind and visually seen?
Yeah, no, that's a really good point. I mean, why shouldn't these natural elements be part of our design feature, right? Like one of the projects I've been working on as a pro bono is a school facility in the middle of nowhere in northern India. And in learning from some of the sort of the vernacular there as well, in that particular climate, the issue has always been where you get 4 months of like excessive rain, and then you have a dry spell pretty much throughout the year. So there's a lot to be learned from sort of the vernacular of architecture and sort of just the urban or rural layouts. But ideas like, step wells, which collected a lot of water and retained it for a long period of time, and it was designed in a way where it wouldn't evaporate as much if it was shaded from the sun. I'm kind of going off topic, but in the school that I designed, one of the ideas was to create these spouts. Instead of covering them all, they were kind of channels. And when it rained a lot, the kids could actually see the water flowing and gushing through these channels and going underground and being collected. And it's not only a just a design feature, but it's something that people can connect with. And the more you understand, I mean, we can call it biophilic design or whatever else you may, but just being aware of like when it rains a lot, you can see this flow of gushing water. Another project we had done was something similar where if we design a plaza, for example, seasonal water would flow through it. So it was designed in a manner when it was dry, you could still kind of step down into this little, almost like a water channel in a more of a natural setting. But again, allowing that water flow instead of putting it underground and hiding it in storm lines, we can make that part of our design process. So there's lots of opportunities to bring that up front and really talk about it.
Varun, again, probably a little off topic, but you're reminding me, we spoke to a researcher who does research on human behavior, and she recently did a study where she was comparing how people associated different types of bodies of water with their personal well-being. And she found that, when people are looking at lakes or around lake water that's sitting still, they're very nostalgic and a lot of times thinking about past events. But when they're seeing things like a waterfall, or to your point, the drain pipe with the water flowing from top to bottom, they're very future forward and very positive about the outcome of the day, which I find very exciting to hear that you designed that type of feature into an education facility, because maybe knowingly, I'll give you that credit, knowingly, you were putting a positive future into these students' minds.
That's a really good point. I mean, that's another thing, right? We don't talk about it enough, but yes, in your research, I've seen that so many times where the environment makes you feel or behave in a certain way, and the impact it has on our sort of mental psyche. And linking these things together is so valuable.
Yeah, it's funny. We're like 3 blocks from the Perot Museum. And when I took my kids through there, they have these great displays and very interactive pieces. But one of the things they did was they have pulled back pieces of the building inside to show how the water flows throughout the building. And of all the things that my 2 kids latched onto, they're like, "Oh, Dad, that's cool." And it was just the water inside the building.
You're going to be architects.
But it's more front of mind. I think, Aaron, one of the things that I've really appreciated and liked about Epic Cleantec is some maybe of the unconventional ways that you guys make people think about water conservation. I think you probably know the one I'm referring to. Do you want to talk about a few of the ways you guys have done that?
Yes. Well, let me give some context for you and your listeners as to my background, which is a bit unconventional. I mean, we are a water technology company, but what's interesting about our story is that all 4 of our co-founders come from outside of water. We have a plant scientist, a nanobiotechnologist, a former Soviet rocket engineer, who's also happens to be my father, and then myself, a recovering, former political operative. Now, before I worked in politics, I wanted to be a veterinarian, and then I wanted to be a chef. And then I wanted to become a rabbi until my rabbi talked me out of becoming a rabbi. Then I was a club promoter for a little bit. So I've done a lot of different stuff, but ultimately all the things that I did and all the things that my co-founders did, none of it was in water. And so we kind of came into this with a fresh perspective of, okay, before starting this company, we were like everyone else walking down the street where we just don't think about water a lot. So how do we translate that into sort of interesting topics? Now, what you were sort of referring to is recycled water. In the water industry, we refer to the yuck factor. There's just this innate reaction people have to recycled water that it is lesser than sort of your typical tap water. All of the amazing technologies we have that can fly our planes and produce life-saving medications and even drive our driverless vehicles now, which are taking over the streets of San Francisco, but still people have a fundamental distrust of recycled water. And as my rocket engineer father would often says, what do you think the astronauts have been drinking in space for decades? We have these technologies. So how do we get people comfortable with it? So what we did was we have one of our first installations in a 40-story high-rise in downtown San Francisco. So we worked with Related, went into this 550 apartment building, put a system in. That system is collecting 7,500 gallons per day of gray water from showers and from laundry. Once that water is put through this advanced purification process, it is so clean that you can drink it. Now, we're only using it today for non-potable applications like flushing toilets and urinals and irrigation, cooling towers and laundry. But we wanted to show people just how clean this water is. And look, I can tell you all day that the water's clean, but why would they take my word for it? So we said, well, how do we really get them comfortable with it? We can offer people to drink it. But people were uncomfortable with that. So then we found out that if we put it in the form of a beer, people were 90% more likely to want to try that water. So what we did was we produced 7,200 beers. We took the purified water from this building, from shower and laundry water, partnered with a local brewery. They made this Kolsch-style ale, and not commercial. This was a not-for-sale product, but it went viral. To date, it's clocked up 4 billion medium impressions. It's won a lot of different awards. Last year, it was named one of Time Magazine's best inventions of the year. Again, not a commercial product. We are not a brewery, in spite of all the people reaching out to our info box. But what it did was, without us having to hammer people saying this water is so clean, we just said, you don't have to take our word for it, but here we are drinking it at the United Nations. Here we are drinking it at the World Economic Forum at Stanford University. I even tried to get it into a reception with President Biden when he was in San Francisco. For whatever reason, his staff would not let me bring in our recycled water beer. But it's finding different ways to tell the water story. And I think that our One Water Brew campaign, which is what we call it, was so incredibly effective in just making the point that with technology, we can take what is considered wastewater and we can turn it into this unbelievable commodity. And that's just one example of some of the more unconventional ways we like to tell the story.
So, Aaron, I think that's a really good point that you're making about, purifying the water and putting it back into public view as something that's not part of the ick factor, but something that people are willing to accept. Because one of the things that we've been seeing in research is that in water scarcity cities, they don't have this relationship with water.
Right.
It's so far, something we've talked about already on this podcast. And so I think it's important that we place water in places where people can see it and can have a relationship with it and respond to it. And it can't always be rainwater, because we have cities that don't get that rainwater, but very few times. So how can we place water and make it more impactful for urban life? And if it is recycled wastewater, who knows the difference? They're seeing clean water. They're feeling that clean water. They're able to interact with that clean water. So it could be a way to recreate urban design around water features that bring back the idea of being sustainable and responsible with our water decisions.
Varun, one of the things that I think is really interesting about the idea of the carbon footprint is it took something that was maybe a little bit more obscure, or people didn't have front of mind, and it's now you can, there's calculators so you know what your commute, what the carbon cost is, or when you go and order something off of Amazon, you can figure out, if I did something next day versus a week from now, how much more carbon footprint per cost. You feel a little bit guilty right now, don't you? Is there something like that where we can begin to introduce the cost of water into everyday decisions that aren't normally associated with water?
Yeah. No, that's a really good point. And yes, we do measure it, right? As professionals in our projects, we do that. But it hasn't caught on as a everyday kind of a metric the way CO2 has caught on. And, understandably, there's an urgency around carbon emissions, and that's what's driving it. But I can see water being the next thing. We should understand what our water footprint is and where we live and how that really starts to give you a perspective on, what are the components that are actually driving your water footprint, right? You might be living in the Northeast, and it's a very different water footprint than what if you're living in Arizona or somewhere else, right? And I think there should be something that brings it up front. That's I think maybe something we should take on and try to push it out.
To that
I don't know
point,
if Aaron is already doing something on that front.
Well, I'm glad you bring it up, because water definitely does not get the same attention as our friends in the energy industry. I mean, just by the numbers, the energy industry and energy startups get about 50 times more federal R&D investment than water. In this bipartisan infrastructure bill, water, while it received funding, was a fraction of what water needs. And I think people don't make the connection between what we call the water energy nexus. I think they separate the two, but ultimately climate change is water change. The effects of climate change are often felt most immediately and most acutely by water, whether it's too little, whether it's, as you said, too much. And to make that connection even stronger, in California, we spend about 20% of all of our electricity and 30% of all of our natural gas focused on water, whether that's through its treatment, its conveyance, through water heating. I mean, in California, we pump water from Northern California over mountains against gravity down to Southern California. The amount of energy expended just to move that water is insane. Now, what if we got to a future where Northern California and Southern California had their own locally sourced water supplies, and we didn't have to pump water over mountains? And I think you're right. It's not something, it's a connection we don't make enough, but we can't sort of separate the two. As I said, climate change is water change. They're inextricably linked. Need to be doing a better job of sort of talking about that water energy nexus.
Well, and anytime you're talking about going against gravity, as you just did, I hear dollar signs. I mean, that's going to cost a pretty penny, and that cost will ultimately go back to the building owners and operators. It'll go back to the end user. And so it is becoming more expensive to live in these cities because of the water usage. Now, we are also in the middle of, I don't know if it's considered a housing crisis, but we are seeing that becoming a resident of a multifamily home is starting to become more palatable to most generations at this point, because home ownership is slipping away so much. And we are seeing, places like Phoenix proposing things like pipelines where they're going to be pumping water from Mexico up to Phoenix so that they can build, because they cannot build without reliable water sources. And so, this whole piping water to different locations. I mean, I also feel personally affected because my hometown lake was piped down here to Dallas, and we no longer have a lake. So,
Really?
Yeah, it was, we went every summer, we jumped off the cliffs, and now there's just rocks there where we used to jump off and swim. And it's kind of sad to see our water basins deteriorating like that, because we're trying to support lifestyles that are no longer, as you mentioned, Aaron, we can't support this status quo anymore.
So let's talk about, from a design perspective, Varun, what are some of the things, certainly, and funny enough, in Ireland, I remember seeing a lot of green roofs. It's something that's, I think, probably more front of mind with designers. Varun, I think on a design level, I'd be curious to know, what are some of the things that designers should think about with water conservation and water responsibility that maybe aren't the more kind of mainstream? Certainly with you being in Ireland, I know you can look out and green roofs are kind of more of a thing there. And so there's living walls, there's a few things that are kind of well known, but what are some of the lesser known design opportunities on a building level to help make a difference?
Yeah, I mean, green roofs have gotten really common, and I think just going back a little bit, I know we've touched upon this in this episode and others as well, where we know that it's no longer simply about conserving water, right? It's also about balancing water, because there are times when we get too much water, there are times when we have no water. And I almost started to think about buildings as being some sort of a sponge, right, which can absorb this water when there's too much and release it over time. Green roof is a perfect technology that we can use. In addition, not many architects are always aware of the fact that we can also design blue roofs. That doesn't take a whole lot more. It's changing basically a detail of the drain, because most roofs, especially when we are in the cold climates, are designed for snow loads. So what it does is it actually allows water to accumulate on the roof for a period of time and then releases it slowly, right? So there's those kind of technologies. There's also ideas and technologies, and even a competition that we worked on with Sam's team, where we were looking at a facade to create a double vaulted kind of a facade that would absorb and hold water, right, over time. I think we got to come up with those, innovative ideas and thoughts, and a number of those can serve a multitude of purposes. So, for example, if the kind of wall that we were kind of tinkling with, that actually creates an additional U value in that wall system, right? It creates an air cavity, but at the same time, it's holding water when it rains. So all the different ideas and innovative thoughts we can bring to the table, where the building itself becomes almost like a sponge, absorbs the water when it needs to, and then releases when we need it. We need to be thinking more in that kind of a thought process of creating a balancing cycle.
When I think to Varun's point, it's not only a benefit to how we're capturing, recapturing, reusing the water, it's also an energy benefit. Green roofs can cool your building down and keep it cooler than buildings without green roofs. And that has a benefit to the building operators who are paying for that energy, but it also has a benefit to the urban environment as well. We've just created so many cities with these huge heat islands that we kind of do need to go back and reassess how we're designing our urban life.
The other piece, I should mention, we tend to lose this connection between building scale and urban scale, right? What Samantha is talking about, and it's that linkage is strong. So I always think about, there's a whole lot of conversation right now about our buildings being efficient and being in sync with the electricity grid. Think about water the same way, right? If our buildings are in sync, and we know a neighborhood can absorb so much water, and think about our urban spaces, the public realm, the rain gardens, you bring it all together, and the capacity can simply grow, and the diversity of these buildings can help us manage the issue of water more efficiently. So I think we need to start thinking at the building scale, but then also be thinking about how that expands into a neighborhood or a city scale.
I know that you have, Aaron, a kind of a background in policy. Is that something, at a building scale, but on an urban level, that is getting some traction or able to become more part of, whether it's building codes or just best practices for design use? Is that something that on, a kind of a code level are able to bubble up and be something that is seen more in design?
Absolutely. I mean, look, if you look at how we design our water and wastewater infrastructure, and this is my history major hat that I'm putting on now. Well, the way we design our infrastructure really hasn't changed since the ancient Romans. With those early aqueduct systems where we're transporting water over vast distances using these big centralized systems. The sewers of London and Paris, which were sort of renowned for really creating the most complicated underground water, or specifically wastewater infrastructure, which, by the way, as a fun fact, the most popular day to visit the famed sewers of Paris is on Valentine's Day. So make of that what you will. But look,
so romantic.
we haven't really changed our design principles in 250 years. Now, what other things that we do in cities have not changed for 250 years? And so we in the water industry, we've been able to learn a lot from the energy world, which is we've moved away from a sole reliance on just centralized infrastructure. So whether it's a nuclear plant, a coal plant, a hydro plant, creating energy and distributing it out, now we have distributed energy. Now we have rooftop solar, we have wind, we have hydro, we have a mix of centralized and decentralized working together to make it more efficient and more resilient. We can do the same thing for water, whether you are creating infrastructure at the building scale or in a group of buildings or at the district scale. So we are seeing that. And one concrete example, just to show you this is not abstract, is in San Francisco. San Francisco now requires that all buildings over 100,000 gross square feet have to have an on-site water recycling system. They need to produce enough recycled water for things like flushing toilets, for irrigation, for cooling towers, for laundry. And this regulation came about in our previous drought. We went from 3 droughts in a row. In 2015, our local officials and our utility came together and said, why are we in the middle of this drought taking fresh water from our national parks to flush the toilets of Twitter's or now X's employees in downtown San Francisco? Why are we using pristine drinking water for applications that don't need pristine drinking water? And so that was the sort of the thesis behind it. There's now at least 100 buildings in San Francisco that either have or will have on-site water reuse, and that playbook is now being adopted by more cities, more states, and more countries. I mean, we've hosted, we're operating more of these on-site systems in San Francisco now than any other company. We've hosted 150 tours in the last 2 years of practitioners in the field, of architects, of engineers, designers, of government leaders from around the world to study this model and to basically use smart policy to actually make this possible. Because in many cases, as I said, we have the technology. It's just old building codes, it's regulations that have made it really hard to kind of scale these types of approaches.
I'm curious, you're talking about this application in California and the policy that you're moving forward in California, which is phenomenal and really exciting to see. I do, have recently seen that the Sunbelt region of the U.S. is becoming more and more water stressed as well. And I'm curious how soon you think that type of policy might move over into Texas, for example, or other states in the Sunbelt area.
Good news. It's already in Texas. So
Yay.
Austin actually very recently passed their own ordinance requiring buildings over 250,000 square feet to have these on-site systems. So we have a team out in Austin because of this. There are now 15 states and the District of Columbia that are all part of a national commission that is studying on-site water reuse to come up with a uniform playbook for how more cities, more states can actually adopt these. And when I talk about the regulation piece, it's actually it's how our company came into being. My father is an MEP engineer. He's been designing high performance buildings for 40 years. And he was approached by a hotel developer in Berkeley, California, who wanted to create the most sustainable green hotel in the world. And, they were looking kind of at every aspect of the building and, in terms of energy conservation, there's a lot out there. When it came to water, they really quickly found out that there's not a huge amount or not as much as there should be. And when it came to wastewater recycling, or what we call on-site water reuse, what they found was that the technologies available were not suited for buildings. We've always designed wastewater technologies to go to a municipal treatment plant where it's big and you can build, there's no clearance issues, there's no odor concerns. Those technologies are not designed for buildings. Then there's the code. How do you bring the water wastewater utility, the Department of Public Health, the Department of Building Inspection, all on the same page to how these systems are actually installed and permitted? So we've figured that out in San Francisco. We now have a 10-step checklist on how these systems can safely be deployed. That is now being copy-pasted to more cities, more states. We as a company, we are doing projects from Hawaii all the way up to the Northeast to Miami. And actually recently just got our first large project in Texas. So what I like to say is that the water reuse revolution is in full swing.
What are the, you were talking about the cost of, having to pump water over the mountains and whatnot, and in the idea of kind of decentralizing water recycling and water management in the same way that power has done. Particularly for the states that are on the coast, like San Francisco or Texas or Florida and the Sun Belt, is there a technology either like, or is desalination something that is able to be done on a micro scale where, different, a group of block of buildings would have their own small desalination plant. Obviously, it's not going to work for some place, in the heart of the country, but on one of the coasts or on, someplace that has access to salt water. Is that a possibility, or is there a different technology that's like that, similar to solar panels, that each building could participate in a micro level?
Yeah, I mean, there's a whole. What we like to say is there's no one single sort of silver bullet solution. There's going to be sort of more of a silver buckshot kind of solution going on, where it's all of the above. So in many places, desalination is a great way of doing things. Take a country like Israel. They recycle 90% of all of their wastewater. They have the most advanced desalination in the world, and they are water secure. And what does that mean is that if it doesn't rain, they are fine. They can generate enough of their own water supplies without being reliant on the weather. So they recycle 90% of their wastewater. Spain is the second, and around 35%. We as a country are somewhere in the single digits, which is, on the one hand, you can look at that and be pessimistic and say, wow, pretty disappointing. On the other hand, the way I view it is very optimistic. Wow, we're at 4% of our wastewater. We can do a lot more. So yes, you can have small scale desal, you can have on-site water reuse, you can have atmospheric water generation, where we are literally pulling water out of the atmosphere, like basically an air conditioning unit. There's so many amazing technologies that we can deploy. And I think whether it's water, whether it's climate tech, and I'll say this and I'll get off my soapbox, but we have all of the technologies that we need available to us today to solve some of our most vexing climate challenges. That's not the problem. It's about deploying them and accelerating the pace of deployment. That's the big focus for us right now. And I think the built environment has a huge role to play, because it is such a core part of our economy. It's such a big part of our business engine. And so that was my way of basically saying, yes, we can do small scale desal, but we can do so much more.
I think that's interesting, because we hit on this earlier, but one important part is, while we have all of the technology and we have the know-how and we know the parts and pieces that need to go into the buildings, the education aspect is so incredibly important, because we're looking at generations who are in school now, whether they be in elementary, middle, high school, or even higher education, who may not have this type of education around water and its usage, but they are generations that are extremely interested in environmental responsibility. And so in order to build the future generations, to be the architects and the engineers that we need, and the policymakers that we need to make all of this come together and happen for our country, so that we can get up into the double digits. And compete is not the right word, but be competitive with other countries in those double digits.
Be a leader.
Yeah, be a leader. There we go. If we're going to build that generation or those generations of leaders, we need better tools to educate them. And I think, Aaron, you've been talking about some ways that you are educating the communities. And I think that that's, really exciting. And hopefully we can start to see that expand.
Yeah. So, Aaron, we've been picking your brain and taking full advantage of your expertise, but we haven't really talked much about the technology that Epic Cleantec uses. Can you tell me a little bit about that?
Yes. So I'm not an engineer, so I'm going to keep this pretty high level. But the core technology that we use is called a membrane bioreactor. And it's a very fancy name, but basically what it means is that we are using membranes. So think of, a lot of people are familiar with reverse osmosis. So we're basically pushing water through a physical barrier with little tiny holes that are 1/1000th the diameter of a human hair. So basically we are filtering the water out like a fancy Brita filter. And then, so that's the membrane piece. And then we use biology. So we are kind of like your human stomach. We are actually growing a microbial environment where we introduce the wastewater in, and we use living bugs to actually break down a lot of the contaminants. I mean, our human stomach, or even what happens in a river in nature. That's just how water is naturally purified. So we are passing water through membranes, using biology, then we disinfect it using ultraviolet light, using chlorine. By the time the water passes through all of these advanced treatment steps, it's going to look, it's going to smell, even taste identical to your tap water. The water itself is the same. The only thing that's different is people's perception of it. But I think what's really interesting is if you zoom out and you kind of look at, well, what can a building really do when it comes to water? The average residential building can reuse about 50% of its water for all these different non-potable applications. And I say non-potable because scientifically the water from our systems is clean enough to drink, but most regulatory areas don't allow us to use it for drinking water just yet. But if you just add up all of the uses, so if we're capturing water from your showers, your toilets, your AC condensate, your dishwashers, your laundry, we can treat that water and then reuse it for 50% of the building's water needs in a multifamily building. For an office building, that can go up to 95%. So wow. 95% of the water generated on the site can be reused on site. And I think to Varun's point, I mean, if you look beyond just conventional residential and office buildings at data centers, which as you noted, the average data center uses the same amount of water as a 50,000 person city. You know, these semiconductor factories that are producing the chips that power every single piece of technology, including this Apple laptop that I'm on today, they all need water. Almost every single type of industrial process uses a huge amount of water. Take a company like Tesla. They're building a new manufacturing facility out in Germany in a place that didn't have water. We see that with data centers. We see that with industrial processes, even with breweries and distilleries. I mean, the average brewery today takes about 10 gallons of water to produce 1 gallon of beer. What if we incorporated on-site water reuse technologies and we got that down to 3 gallons to 1 gallon of product? You know, you take companies like Pepsi and Coke, they start incorporating this stuff into their processes. There's huge water savings, which they are not needing to draw out from the local supply. So any way that you look at it, whether it's an office building, a multifamily building, a data center, a brewery, or a Tesla factory, every single one of them can make use of these water reuse technologies. And it's an exciting time to be in the water world.
Well, that's a good setup, and Varun, we'll start this with you. I know we could continue this conversation for 12 more hours, but Varun, you've got a Taylor Swift concert to get to. So let's. I want to wrap up kind of a little bit of a lightning round of the biggest blind spots you think we have right now that people may not know about, and then the thing that designers or we as advocates can do, one of the single most important things we can do to push this issue forward and to move the needle, as it were. So let's start with the blind spots, and we'll start with you, Varun.
Yeah, I think we talked a little bit about this quantification thing, right? And I think that, we can overcome a blind spot. And to Aaron's point, the water consumption in different buildings, and we do a lot of data centers, we do aviation projects, and being cognizant about how much water can actually be saved in these buildings. I mean, we're talking about cooling towers in data centers that can consume enormous amount of water. And on the flip side, how much water can actually be absorbed, right? Like if you think about the surface area on an airport terminal, that's huge. How much water can you actually collect from that roof and do something with it is another piece, apart from recycling and reusing the water from on site. So I think being aware of some of those metrics and values and numbers and being aware of the technology is really, really helpful. I don't know if that's exactly a blind side, but not knowing it is a blind side. Mm-hmm. And then, just in terms of like where we can have the biggest impact, I keep going back to thinking this issue beyond the boundaries of the United States, and where it's no longer an inconvenience at the moment. It's a life and death kind of situation in many, many parts of the world. And some of these parts of the world are also building the most, developing the most amount of kind of urban centers. And how can we develop technologies and ideas and bring them out there as well, where it's most needed? I think it's going to be really helpful in moving the needle.
Love that. Aaron?
I think to build off of Varun's point, it's again, taking us here, sitting in the United States, I think we often think about water challenges as something that is not here. It's out there. It's in the developing world. And so much of the people who've been focused on solving water issues, it's largely been relegated to NGOs and nonprofits and governments. That needs to change. And I think a lot of people don't necessarily realize that these technologies and these solutions exist today. I mean, just as an example, we are now operating the largest in-building water recycling system in the Salesforce Tower in San Francisco, which is the most prominent building, the tallest building in San Francisco, has a 30,000 gallon per day black water system. We're operating a system now in the Waldorf Astoria in Beverly Hills. These are huge, iconic brands that are making this a central part of their story. And I think we can do so much more to put this water conversation at the center of the story. This is not something that's off there, not affecting us, but it's also something we have solutions for today.
Love that. Sam?
Yeah, I mean, I will take a note from Aaron and build off of Varun's point. If we're not measuring it, we are not educated about it. We don't know where to start, and we don't know what a solution could be or where there's even a problem. And so I think, to my earlier point, I think it's extremely important that we find ways to educate not only the coming generations who will be end users and potential policymakers and designers, but we also need to be educating our clients, and we need to be educating our designers, and we need to be educating our suppliers and our contractors. And I think together we can kind of build that education. And I don't mean that we as Corgan or we as Samantha Flores need to go out and teach everybody. But I think we, as the AEC industry, should be building knowledge around this topic. And I think to that point, what we need to be doing as a society is building the passion for water that we see with Aaron. Because I think, once we can build that in future generations, we're only going to start to see that grow, just like we have with the carbon footprint discussion that we had earlier. There has to be a passion for people to move forward en masse in order for us to take the right steps to move forward to the right solutions.
Well, this is a conversation that could continue on for hours and hours, but Varun has, it's not going to get old, Varun. I'm going to keep making that joke. You have a Taylor Swift concert to get to. But thank you so much for joining us from Dublin. Aaron, thank you so much for joining us from LA. Samantha, thank you for being here.
Of course.
And thank you for watching. If you want to know more about Aaron and Epic Cleantec, we'll make sure to put links for how to contact him and find out more in the description. And make sure to check out the next episode in this series on water coming up soon.